Greeting class, greeting untuk pada My name is Daffari Putri Utami, and in this video we'll talk about optimization. First, I'm going to talk about optimization in general, and then I'm going to move into one and multi-dimensional optimization. First, general optimization. So, optimization mathematically is the mathematical procedure as finding the maximum of a function. If we're taking a peek at the picture, we can see the curve and its minimum and maximum point. So basically, we have to find this maximum point in some of the system. And optimization also can be classified by form of function x and its constraint problem and also dimensionality. And in this video, we will be focusing on the dimensionality. So first, we're going to talk about the one-dimensional optimization. And the first method is golden section search, where the golden section search is a very great method, but it's very time consuming. And why it's very time consuming? Because this method has many variations, and the golden section search method is actually similar to the bisection method in solving for the root of a single nonlinear equation. And this golden section search method can be achieved by specifying that the following two conditions hold R, where R is a golden ratio. And this is also the illustration of the golden section search method. Second is quadratic interpolation, where the quadratic interpolation is actually advanced system of the interpolation where the quadratic interpolation takes advantage of the fact that the second order polynomial often provides a good approximation to the shape of function x near an optimum. And here is the formulas for the quadratic interpolations. We can use this formula easily. And then third, Newton's method. So at an optimum and the optimal value, where the optimal value is x, we satisfy that the first derivative is equal to 0. With the second order Taylor series of function x, we can find the following equation for an estimate of the optimal with the formulas below. And then we're going to move into multi-dimensional optimization. First is the direct methods. These direct methods is actually very complicated, where we can use these methods with a random search or unvariate search, where in random search we repeatedly evaluate the function at randomly selected values of the independent variables. And in unvariate search, we change one variable at a time to improve the approximation, while the other variables are held constant. And since only one variable is changed, the problem reduced to a sequence of one-dimensional search. And here is the picture of conjugate directions. And second is gradient methods. So gradient methods use derivative information to generate efficient algorithms to look at optimum point, where the gradient is defined as these formulas, and the derivative information for this formula, where the first derivative is whether it is an optimal, and second derivative where it called as Hessian and symboled as H. And here are the rules for the Hessian, where it is absolute, and by a lot of derivatives we can get the lambda for the optimization by these formulas. And that's actually my very brief explanation of the optimization and its example methods for the dimensional as it classified by its dimension. And last but not least, code by Eckhart Tolle in his book The Power of Now, A Guide to Spiritual Enlightenment. If your mind carries a heavy burden of past, you will experience more of the same. The past perpetuates itself through lack of presence. The quality of your consciousness at this point is what shapes the future. So stay conscious and shapes your future into a better one. Thank you very much for listening.